In this video, we're going to look at how we can use moles to count the number of atoms we have in something. So, for example, here I've got a container with a bunch of chunks of carbon in it. I want to know, how many carbon atoms do I have here? We'll learn how to figure that out here. So, just a quick review of moles. A mole is kind of like a dozen, except there are 12 things in a dozen, and there are 602 hexillion things in a mole, and we often abbreviate this number in scientific notation as 6.02 times 10 to the 23rd. Now let's take a look at a mole. Right here I have a mole of sulfur atoms, which is just about 602 hexillion sulfur atoms. Now this is pretty crazy because it's such a giant number of sulfur atoms. Here's my question. How do I know that there are 602 hexillion sulfur atoms here, right? I couldn't count them out for two reasons. One, atoms are way too tiny, right? We can't even see them with a very powerful microscope. So there's no way that I could have seen the atoms and counted them out. Second of all, even if I could count out the sulfur atoms, there are so many things in a mole that it would take 20 quadrillion years to count from 0 up to a mole. So even if I could see these atoms, there's no way I could count them out. Yet I'm pretty confident that there are pretty close to 602 hexillion sulfur atoms in here. How do I know that? Well, we're going to learn more about this, but it turns out that I can figure out how much a mole, 602 hexillion sulfur atoms, weigh, and then I can put this thing on a scale and weigh out that number of sulfur atoms. Let's talk a little bit more about this so it makes a little bit more sense. Okay, so here's an analogy. Let's say that I work at a candy factory, and when someone places an order, it's my job to count out all the pieces of candy that they ordered. Okay? One day, a giant rush job comes in for 10,000 jelly beans, and the person who placed this order wants exactly 10,000 jelly beans. What a pain this is going to be, right? I got a 1, 2, 3, count out 10,000 jelly beans. It's like going to take all day. What could make my life a whole lot easier? Well, one thing that would be really awesome is if I knew how much 10,000 jelly beans weighs, right? So what if I figured out that 10,000 jelly beans weigh 27,130 grams? That would be really awesome because then all I would have to do is put a big bag on a scale and just shovel the jelly beans in until I got 27,130 grams of them. So in other words, instead of having to count, if I know how much 10,000 jelly beans weigh, all I gotta do is weigh out that amount. We can do the exact same thing here with moles. I told you there's about 602 hexillion sulfur atoms here. Of course I didn't count that out. That's because I know that 602 hexillion sulfur atoms, a mole of sulfur atoms, weighs just about 32.07 grams. So all I got to do is put this container on a scale, weigh out 32.07 grams, and I know I have just about 602 hexillion of them. So how did I know that a mole of sulfur atoms weighed 32.07 grams? Well, all you got to do is look at the periodic table. If I look sulfur up on the periodic table, I've got the element name and the abbreviation and stuff, and then I got this number down here. This is what we call the molar mass. And this number down here tells us how much one mole of this element weighs in grams. So 32.07 is how much one mole, 602 hexillion sulfur atoms, weighs. Now, let's go back to the candy factory. Imagine that I get all kinds of orders for all sorts of different candies. I can figure out what 10,000 of many different types of candies weigh. So, for example, maybe I have to do M&Ms one day, and I can find out that 10,000 M&Ms weigh 8,770 grams. They weigh less because one M&M is much lighter than one jelly bean. So 10,000 of them are going to weigh less. On the other hand, a candy like one of these chocolate malted balls, very delicious, are a bunch heavier than the jelly beans. So 10,000 malted balls are going to weigh a bunch more, 154 1,600 grams. So it's the same way with atoms. Some are lighter and some are heavier. So carbon, for example, is a little bit lighter than sulfur. And 602 hexillion carbon atoms only weigh about 12.01 grams because carbon atoms are just lighter than sulfur atoms. On the other hand, something like zinc atoms are heavier than sulfur atoms. So 602 hexillion zinc atoms, a mole of zinc atoms, weigh 65.38 grams. And just as I did with sulfur, I know how much the carbon and zinc moles weigh because I can look up the atoms on the periodic table. So here we got carbon, 12.01 is its molar mass. That's how much 1 mole weighs. And zinc, look that up on the periodic table, 65.38, and that tells me how much 1 mole of zinc, 602 hexillion zinc atoms weigh. So, if I want 602 hexillion, 1 mole, of any kind of atom, all I gotta do is look on the periodic table and find out how much a mole of that atom weighs. And then I don't have to count any atoms. All I have to do is just weigh out this amount on a scale. This is just like me being lazy in the candy factory. I don't want to have to count out these jelly beans or M&Ms, so I can just weigh them instead. I can do all my counting by weighing. And that's what I do with these atoms. I count by weighing out their molar masses. So, now that we know how to figure out how much a mole of atoms weighs, let's go back to that original question that I asked at the beginning of the video. I have here in this container a whole bunch of carbon. I want to know how many atoms of carbon are in here. Let's see how we'll answer this. Okay, so how many atoms of carbon do I have in this container? Well, let's think about moles of carbon. I look up carbon on the periodic table and I find out that 1 mole weighs 12.01 grams. And I also know that in that 1 mole, there are 602 hexillion atoms. So the first thing I want to know is how many moles of carbon do I have here? In order to figure that out, we can do some weighing, all right? I know that 1 mole weighs 12.01 grams, so let's weigh this and figure out how many total moles we have in here. I put this on the scale and find out that there are 31.87 grams of carbon atoms in here. Now that's more than a mole. If we had 12.01 grams of carbon, we'd have 1 mole, but we have more than that. So let's figure out how many total moles we have. We'll do that by taking 31.87 grams, the total mass of carbon atoms here, and divide that by 12.01 grams, which is how much 1 mole weighs. And when we do that, we get 2.654 moles. So that is how many moles of carbon I have in here. Okay, we'll take this number, hold on to it, because it's going to be important for what we do next. Okay, so how many atoms of carbon do I have in here? Well, we know that in each mole, there are 602 hexillion atoms, but here I've got 2.654 moles. Okay, this isn't too hard though, because all I got to do is multiply 2.654 by the number of atoms that are in 1 mole. So I can do 2.654 moles times 602 hexillion atoms. Now, this is kind of a pain because I got all these zeros, so I'm going to rewrite this using the shortened version of this in scientific notation. Let me just move this up, and instead I'm going to multiply this by 6.02 times 10 to the 23rd, which is usually the version of 602 hexillion that we want to use when we're doing math. When I do this, I can just plug it into a calculator. I'm going to get 1.60 times 10 to the 24th carbon atoms. Oh, I forgot the R. Carbon atoms. There we go. And now, again, sometimes when you see things in scientific notation, it can be a little bit scary, a little bit tricky. So let's put this out of scientific notation. And this is the number of carbon atoms that we have when we put all those zeros in. A whole bunch. 1 heptrillion, 600 hexillion carbon atoms. So that is how we can use moles to figure out the number of atoms we have in something. We can figure out how many moles we have by weighing it, and then once we know how many moles we have, all we've got to do is multiply that by the number of things that are in a mole, and we get our final answer.